I'll maybe I have prepared a few slides. Let me start by sharing them, and then we can take it forward. Let me know when you can see my screen. Do you guys see it?
Yes, sir, your screen is visible.
Okay, great. Okay. Hello, everyone. As the introduction said, I'm Gaurav. I graduated in 2018, and then I started my career with Goldman Sachs as a software engineer. Then, obviously, I was passionate about machine learning and wanted to work on machine learning, and I switched my job and started working at GeoHaptic. And as the unfortunately, uh, I decided to leave GeoHaptic. And yesterday was my last day. I'm joining now Amazon this Monday. So this ML engineer at Haptic is a outdated designation, but yeah. So currently I'll be applied scientist at Amazon, and I've published 4 papers which have been accepted at these top tier conferences, and my work has been fortunately appreciated a lot by the community. One of them being the INLTK library, which I created, and has quite a few downloads and 700 plus stars on GitHub. Uh, and then obviously because of all of this work which I did, all of these papers, I ended up getting the Indian Achievers Award last year. uh, and yeah, this so this was just a bit of background about me. And I would like this, the reason I'm saying this is so uh, I started uh, doing all of this stuff in maybe 2018, or in the last quarter of 2017. And this has been my journey for past 3-4 years. And I'll try and share what I've done, and I mean what I've done, because of which I've achieved these results. And I hope many of you will be able to achieve better results than these, and excel in your careers. So as the topic of the and one another thing which I really want to say is, feel free to ask any questions, and I'll be happy to answer them midway, or even after these slides end. I really want this session to be interactive, and I really want that I am able to deliver value in this 1 hour. And I'll be happy to answer any question which you might have, uh, closely related to software engineering, computer science, machine learning, and all that stuff. So let's get started. uh, to start with, machine learning is a huge buzzword, and everyone seems to be interested in machine learning, which is a good thing, and a bit of bad thing as well, maybe. But the machine learning, it takes a lot to be a good professional at machine learning, and these are some of the skills which I think have been important in my success with machine learning, and whatever I've been able to do. First thing first, I was told that most of the people in this webinar will be from second, third year, or first year. So I would say that the first and foremost thing to get right when you are in college is, to be good at data structures and algorithms and your programming skills. This is the foundation of, almost everything which you will do for the next 10, 20 years, if you choose to be if you choose to be in this field, and to choose to do software engineering, machine learning, research, etc. So, this is the foundation, and uh, there's no shortcut to this. You have to put in the necessary effort to get these skills right. And competitive programming, web dev projects, internships, these are multiple ways in which you can get this right. But there's no substitute for this. Let me put it this way. You cannot jump to machine learning or deep learning without having good enough background in software engineering or with your problem solving and coding skills. So that is a must have. And that is the first thing which you should try and build for yourself if you're not there yet. Then secondly, machine learning, so things are getting democratized. And what I mean by democratized is, things which were very, very difficult to code and get right maybe 3 years from today, are very easy. Only 10 lines of code in Python today. So if you want, any one of you can today build a speech recognition system for Hindi, let's say speech to text system. In a Colab notebook, and maybe in 3 to 4 hours, just by looking at notebooks and blogs which are there all over the internet. So things will change. If things have changed in the past 3 years, things are going to change, in the next 3 years as well. These pace at which this technology is changing and improving and getting democratized is unbelievable. And it is a huge challenge, as a ML professional, to keep up with this pace. So so the point which I want to bring home from this is that you need to be good with your fundamentals. Fundamentals never change. As long as you are good with your problem solving skills, your coding skills in at least one language, and have reasonable grasp over linear algebra, calculus, and probability concepts, you should be able to, I mean, get familiar with the new research which is happening and be able to solve business problems with that. So, I mean, these first two fundamentals are key to whatever you'll do in machine learning if you want to be a ML professional. And I mean, it is a it is a very good investment to focus on all of these concepts and your coding skills in the initial part of your college, uh, so that you can then pick up anything you want. And it's not just about machine learning. Let's say you want to go into security. You'll need these skills there as well. You need to go into computer networking, you'll need these skills over there as well. So these are different verticals out of computer science, but you will need these fundamentals everywhere. And I mean from the looks of it, I mean, 3 years down the line, 5 years down the line, people who will be very, very successful with machine learning will need to have these fundamental skills, right? Otherwise, like in maybe let's say web development or other, lot of other things, everything is going to be an API, and it has already started to be that way in machine learning as well. A lot of people are getting into this field and developing a lot of tools, libraries, all of this stuff for other developers, and then you can just plug and play all of those libraries to get results whatever you want. So one of the examples for this is the library which I built, INLTK. So what it does is it provides you out of the box support for quite a few NLP functionalities for Indic languages. You don't need to know MLDL concepts to use that library. And this has happened because more and more people are getting into this space and using tools, and all of this ecosystem is getting better and better. But and obviously, what's the latest and greatest in, let's say, NLP today, was not there 2 years or 3 years from now. State of the art is always going to keep changing, but these fundamental concepts will remain strong. So if there's one thing which you want to take away from this webinar, it has to be this: get very good with your fundamentals, and then world is yours, and you can pick up anything and everything which you want. Okay. Moving on. So once you have these fundamentals right from coding and mathematics perspectives, uh, it's the right time to get your ML or DL concepts. And I have a slide with a link, which from where you can get, the resources as to from where you can pick up these concepts. But uh, and then so I'll tell you how I approached this problem. So ML in itself is a big ocean. There's classical machine learning, there's deep learning, there's reinforcement learning, there are now graph neural networks as well. Then these are different techniques which you can apply, but then there are different problem spaces as well. There's NLP, there's computer vision, there's recommendation systems, and there's augmented reality, which is a part of maybe computer vision. But there are these so many different techniques and so many different problems, which can be solved using machine learning. So it is always good to be, have uh, have a good enough idea of, have a good enough breadth and depth. So what I mean by this statement is, it is important to know, fundamental concepts which are used across all of these problem statements and all of these techniques. But it is, then a good idea to focus on a vertical. So what I did is focused on NLP. I tried to, come up as an expert, or I'm no, I'm very far from an expert, but this is what I tried. I tried to focus on NLP and tried to do most of my work in NLP. And then obviously I was working with Haptic in the conversational AI space. And uh, I got very familiar with whatever the research work is going on, what are the problems which industry is facing, which need to be solved, and all of my papers came out of that understanding. Once you go deep into a field, then only you can recognize that these are the problems which exist in that field, and by contributing, or by solving these problems, you can contribute to that field and move it forward. That's what the job of a researcher, or that's what the point is behind publishing papers, that you want to take the field forward. And that's what I did for NLP. uh, okay, moving on. Uh, so these are the possible paths which one can take to 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 be a ML professional. And I mean, I'll tell you how easy or difficult it is to, follow and achieve your end result, which you're looking for each one of these paths. But let me go through these three paths first. So essentially, I am assuming all of you are currently pursuing your bachelor's. Since the field has matured a bit, and a lot of people have lot of interest, and the uh, supply of people to do ML, NLP, CV, etc. is more than maybe what people need. It's a completely different thing that there are not maybe many people who are qualified, and uh, are have reasonable skills to do the job. but that's why there's scarcity and everyone is looking for ML professionals. But at least, I mean, there's a lot of interest, and because of that, I mean, it it is reasonably difficult to get a ML job right out of your bachelor's, in a big tech, in a I mean in a reasonably mature company. If you'll go and look at their job, I mean, responsibilities and qualifications, let's say go on, I mean, Google's career website or Amazon's careers website, or I mean any of these, Facebook, Apple, any of these companies, you'll most likely see at least a master's or a PhD requirement. And so that is one path which people usually follow. They, if let's say you are fixed upon this thing that you want to have a ML career, uh, it is a reasonable choice to go for a master's. And then if you are, I mean, really into research, then you can get, I mean, industry ML or academic ML jobs. So this is the first path. Second path is, I mean, you try and get a ML related job in a startup. So early stage startups, I mean, do give opportunities to people who might not have, I mean, these qualifications, but have proved them in themselves in some other way. And obviously, I mean, if you have no projects, open source contributions, or maybe internships, or I mean, no ML background on your resume, it is very difficult to get a ML job in a startup as well. So you need to prove that you have the knowledge and some sort of skills, which you can use to contribute. But I mean, it is relatively easier to join a startup and do ML over there than join, let's say, Amazon, Facebook, Apple, etc., all of these big companies, and do ML over there right after completing your bachelor's. Now, there are few exceptions which I've seen to this thing. I've seen a lot of people who do integrated masters in IITs. So that is a 5 years, I guess, masters plus bachelor's degree. I see a lot of people from that kind of background getting hired into ML roles in big tech as well. So I mean, obviously there are, I mean, these exceptions all over the place, but I mean, it is relatively difficult. So it's good to accept that fact. And then obviously third path which I see a lot of my friends taking is, I mean, get into a company whichever you want. I mean, let's say it is a reasonably sized company, and then you try and switch internally to a ML specific role. So for that also, I mean, you need to put in ML related effort. You need to do the courses, you need to do, some of the companies have their own internal, I mean, structured paths which can take you from, let's say, a SD role to a ML role. And I mean, so these are three possible paths. And if you have to, I mean, so like most of you can, I mean, maybe recognize, I took the path two. I completed my bachelor's. I started with the SD role in Goldman Sachs. And I mean, by the time of, I mean, by 2019, I guess I had figured out that I want to be in ML space. I did manage to get a reasonable, I mean, job in Goldman Sachs as well, for a, I mean, ML role, which could have helped me to transition to maybe a data scientist, etc., that over there. But I mean, parallelly, I got this offer from GeoHaptic to work in the NLP conversational AI space, which was closer to what I wanted to do. And that's why, I mean, I moved to GeoHaptic. And now, as things have turned out, I mean, I've moved to Amazon to do ML over there. So path two was for me, and you have to decide, I mean, which path you want to take. I see something happened. Uh, what would be the basic projects to start with ML? Okay, great question. Yeah, I have this question answered on the slide. Let's reach there, and then I'll answer. Uh, But moving on from what I was discussing, I mean, in industry, I mean, so I mean, depending upon the path which you pick, you should also be aware about different designations. I mean, which are floating around ML roles. And I mean, obviously this field is maturing and industry is maturing, and these roles are relatively new. So I mean, all of these designations and names and roles and responsibilities, I mean, aren't really as figured out as they are for, let's say, SD roles. So I mean, in a startup, you can, I mean, depending upon how mature that startup is, you can expect yourself to do, I mean, let's say if you're an ML engineer, you can expect yourself to do research work as well, ML engineering work as well, and software engineering work as well. And I'll try and break down as to what each one of these roles entails. So ML research role, again, I mean, can be divided into two parts. One of them could be applied research, and one of those could be, I mean, your core research. So applied research is usually, I mean, you have all of these algorithms and I mean, all of this of all of these techniques which are there, and you're given a business problem which you need to solve using those algorithms. So I mean, you need to s- start by defining what your business problem is, convert it into an ML formulation, convert, and then try and break down as to what would be the metrics which you want to track, which would eventually lead to success for business. So these are the metrics which you want to identify, and then do all of these experiments and then build a POC. So this is usually the role of an applied researcher. Whereas I mean, if you're into core research, then you are most probably, I mean, trying to find a better I mean, just one example over here to give is, I mean, let's say you're trying to find a better optimization technique. I mean, what can you do other than, let's say, gradient descent to, I mean, to so that models fit better. So these are two broad types of research categories. And then in ML engineering, I mean, different people have different definitions. Uh, in some companies, the role of an ML engineer is to, I mean, your research scientists and your researchers will give you models, and your job is to take that model from POC stage to into production. And then I mean, your ML engineers and software engineers are a bit tied, I mean, in some companies, and their roles overlap. But yeah, I mean, these are different roles and responsibilities. And then in mature companies, I mean, you have data scientists are usually trying to solve, I mean, more towards I mean, their work is more related towards business problems and identifying how can things be optimized for the business. Software engineer in ML and ML engineer are used very, I mean, interchangeably. And then the third kind of role is of that of, I mean, your applied scientist is, I mean, applying all of these ML techniques to solve a business problem. And then, I mean, your recent research scientists are more towards solving core problems, like let's say core algorithmic problems, like, let's say, I mean, that gradient descent example which I gave. Now to I mean, so one of the I mean, frequently asked questions which I mean, must be there in everyone's mind over here as well, is how can I get started with ML on my own? I mean, so the first two things which you really need to do are getting your programming and DS algo problem solving fundamentals right. And then second thing is, I mean, getting your mathematics skills right. So this thread, I mean, I'll be able to share these PPT slides as well with you. But this thread essentially contains all of the stuff which you need. And I mean, I've personally followed this thread, and this thread contains, I mean, a lot of great material, which all of it is, I mean, freely available online, and is there. I mean, it is from one of the top universities in the world as well. So, like I said, I mean, the first one is probability and statistics by Stanford, then linear algebra by MIT. Then, I mean, There's this CNN course by Stanford. This one is one of my favorites. Practical Deep Learning for Coders by FastAI. Uh, then obviously, I mean, machine learning by Andrew Ng. Uh, and some of these advanced courses as well, on graphical models and reinforcement learning. And essentially, I mean, if you follow this material, I mean, you should be well versed with all of the stuff which goes in ML. And if you really do it well, I mean, you'll be very good, I think. Now to I mean, so this is how do you gain knowledge. You need to also apply that knowledge somewhere, otherwise, I mean, you're going to forget it. And I mean, these are few things which I was able to think of. One of them is, I mean, I've seen GSOC, Google Son of Code, and Outreachy, and I mean, I can't remember if there are any other such competitions, but I mean, these two are very popular, and these two do contain, I mean, these are specially, I mean, targeted at, first of all, for college students, so you do not have any competition from, let's say, professionals. Then second thing is, I mean, these competitions do contain a lot of ML projects from, I mean, good open source projects, which I mean, you can put an effort, and lot of things which you really need to do are streamlined and, I mean, are well defined by the organizers, so that, I mean, you don't get lost. And obviously, I mean, during this internship of GSOC and Outreachy, you'll have, I mean, a mentor assigned to you as well. So I don't see a better opportunity than to try and crack. I mean, try and get one of the ML projects in. I mean, in GSOC or in Outreachy, and that will be a great experience. So that is first thing, which I mean, which you can try and do. Then another thing, I mean, which can be done is, I guess, once you have figured out, I mean, that, I mean, maybe you want to focus on this vertical, let's say NLP. Now, I mean, it is a good idea to try and filter on GitHub what are the top trending repositories. I mean, let's say for Python and NLP, and most likely, I mean, you'll find, I mean, quite a few good repositories. One of them is, let's say, Hugging Faces Transformers library. So this library has taken the world by storm, and I mean, has completely democratized NLP. And it very recently, this, I mean, these guys hosted I mean, a community effort where they gave all of these scripts and, I mean, data and compute power to train ASR models. Uh, and I mean, I did see, I mean, quite a few people, I mean, trying to contribute for, let's say, Indic languages, ASR models for Indic languages. So, and I mean, so this is one example. And I do believe, I mean, there are a lot of good libraries which have quite a few issues, I mean, which can be fixed, which are low hanging fruits. And I mean, people want, I mean, help from the community to solve those issues. And I mean, one of the examples is, let's say, INLTK library, which I have quite a few issues on the library itself, which, I mean, I really am not able to find time to solve those issues, and those aren't, I mean, too difficult to be solved. So a good first thing to do over there could be, I mean, try and contribute, let's say, to INLTK. So, or I mean, any other library which you can find and on GitHub. And the, I mean, the way you identify those libraries is GitHub filters. Usually, I mean, these big libraries which have a lot of stars and contributors have a lot of people who are ready to help you. And I mean, people are generally very nice. So it's just that starting step which you need to take. And obviously, I mean, you need to have some background knowledge and necessary skills before that, because, I mean, obviously, you cannot expect people to be teaching you each and every small thing. But as long as, I mean, you have reasonable grasp of the coding language and, I mean, ML concepts, you should be able to make your way through. And yeah, I mean, so these are the two ideas which I had. Does this actually, I mean, I guess this is the material which I had prepared, and I really want to answer your questions now. Uh, so this first thing, what would be the basic projects to start with ML? So this slide which says I mean GSOC outreach ML projects where you'll get mentorship and I mean a plan to do things, and you'll I mean obviously receive a stipend as well. So this is the best thing to go for, I guess. The other thing could also be, I mean, once you if you can get this right, other thing then could be, I mean, try and do a ML internship in a startup. So that is another possibility. And then obviously, I mean, this GitHub issues and open source contributions is going to take some amount of effort from your side, and you'll not have things as planned as they will be, I guess, in GSOC and Outreachy. But still, I mean, people in the community are very good and will be able to help you if you have enough motivation and drive to do things. So this let me know if this still doesn't answer your question. Uh, I'll move on to the next one. Generally, there's a confusion between uh, generally there's a confusion between AI, deep learning, and ML. How different are they in practical sense? So, I mean, if you've seen a Venn diagram, AI is your outer circle, then ML is the middle circle, and then deep learning is the innermost circle. And I mean, so obviously, I mean, there are core concepts which from ML which are used in deep learning. Let's say cross validation, let's say overfitting, let's say bias variance trade-off. So all of these things are, I mean, concepts which will be used in, I mean, in any ML project. I mean, no matter what you do. So I mean, it is important to uh, have a have an idea of all of these ML concepts and then move to deep learning. AI in general again is a I mean is a again a combination of all of these techniques. So I mean one major difference in ML and AI is that in ML you are trying to learn from experience. You have lot of data, and you have a lot of data and you try and frame it as an optimization problem, and then I mean learn from experience and improve with experience. Whereas in AI, I mean it consists of a lot of other techniques as well. Let's say semantic networks, let's say Markov models, and all of this stuff comes under, I mean, in Bayesian models, all of this stuff comes under AI. And I believe, I mean, the right, I mean, path to take over here is to do AI, then ML, then DL. Because I mean, let's say if you jump directly to DL and you don't know what overfitting, generalization, what metrics are, and then I mean what cross validation is, then I don't think, I mean, you'll be able to do justice to material and do justice to yourself. So that's it, I guess. Moving on to the next question. If an undergraduate has published a research paper in CV or NLP, so how helpful will it be in landing an ML job? I guess it will surely, I mean, be helpful in the sense that uh, you'll have a, I mean, a reasonable thing which you can put forward to the people on the other side of the table, that I mean you have done some work which has been peer reviewed in a good enough research conference, and I mean you know this stuff basically. And I would say, I mean, to land a job in a, let's say, big tech or in mature companies, people do look out for, I mean, research papers and good conferences. And if you'll go, let's say, on, let's say, Google's career page or Amazon's careers page or Facebook, you'll see that, I mean, all of these these companies have this, I mean, preferred requirement that it will be great if you can if you have published papers in top tier conferences, like, I mean, let's say for NLP it is EMNLP, EACL, ACL. For CV it is, I mean, let's say CVPR or ICLR. So all of these conferences do make a strong, I mean, mark on the interviewer, and really helps. And this has been my personal experience as well. I mean, these papers do help a lot. Next one. If one has done a course on ML and data science, made a few projects, how should he go about landing an internship in this field? Hmm. So, I mean, the best way to get this thing done and get a job or an internship is to try and have a referral. Uh, so I mean, so obviously, I mean, one thing which you can obviously do is try and apply for a job on, let's say, LinkedIn, or on the company's careers website. But I mean, a better way to do it is, I mean, if you know someone, or I mean, you can obviously cold email people on LinkedIn as well. It is important to be nice, but I mean, if you have done relevant work and you fit the criteria which is, I mean, needed for that job or that internship, people will be very, very happy to refer you. And so I mean, these referrals are, I think, I mean, one of the best ways to go about this thing. If you feel, I mean, you have reasonable skills and I mean, material on your resume which can do justice to that job. Okay. Next one, how can first year student get any internships? So I mean, I know there are these, I mean, summer breaks and in PEC, and so I would highly suggest you to, I mean, at least have one summer, I mean, one summer, maybe, I mean, right after your first year, to focus on your core software engineering skills. Let's say, I mean, if you land an internship in a company after right after your first year, but your, I mean, DS algo problem solving skills are not that good, you might not be able to do justice over there, and you might not be able to learn too much as well. So, I mean, first thing to make sure again is to not run after internships, and I mean, try and get your fundamentals right first. If you feel you have that right, then I mean, I mean, I do think that companies will be little skeptical to offer an internship maybe to a first right after your first year. But obviously you can try, and the way to go about it, that again, is to try and reach out to people on LinkedIn, try and I mean, apply on careers websites, LinkedIn jobs, reach out to recruiters, reach out to people who you know in that particular company, and I mean, then try and go from there. Next one, I guess, is for deep learning. We require large amount of data. My question is, from where the data set. My question is, how would we career in providing that data set? I so I mean, my best understanding of this question is, I mean, in competitions like Kaggle. So yeah, Kaggle is again a very, very good platform to showcase your ML skills. And I mean, if let's say, one another thing to add to this question is how to get started with ML is, I mean, try and participate in Kaggle competitions. People do look out for, I mean, good enough ranks, which you, I mean, which if you can get in Kaggle competitions, it will be a great, I mean, thing to have on your resume. Uh, but coming back to this question, I mean, yeah. So my best guess as this question is, that in Kaggle, I mean, you really get your data right from the organizers of the competition, and you only have to focus on ML part, modeling part. And in the real world in industry, uh, ML modeling is a part of a big pipeline. I mean, so let's say, I mean, if you are in industry, you will get a business problem that you want to improve recommendations, let's say on Amazon. Now this is a business problem. You need to define a ML formulation for this. Then you need to define, I mean, how are you going to get your training and test data? No one is going to give it to you. And I mean, by far, I mean, so this thing is now coming up even more in ML NLP space, that you really need to focus on your data. And I mean, the principle is garbage in and garbage out. If your data is not right, your results are, I mean, not going to be right, no matter what algorithm you use. So uh, I mean, you really need to focus on this data part as well. And the best way to do that is not on Kaggle, but by trying to, I mean, build a project of your own. Or I mean, if you can get industry experience by doing internships or job, I mean, nothing like that. But I mean, if you try and, let's say, pick up a project of your own. So what the first project which I built for ML was to predict if a competitive programming problem will need a dynamic programming concept or a binary search or all of these concepts. So, I mean, given a question, I want to know from the model that if this question will require DP or binary search or graph algorithm or DFS, BFS, etc. So this was the end-to-end problem which I solved. And I mean, I only ended up collecting all of the data. I prepared the train and test sets, and I then finally also ended up deploying. So this end-to-end experience is, I mean, worth in gold. And this is what Kaggle essentially misses. And one thing which Kaggle really helps you with is the modeling part, which, I mean, no doubt is very important, but other pipeline parts are also very important. And best way to get good with them is, I mean, to maybe, if you can, do an internship or a job, or else, I mean, try and build a project of your own. Next is, what's the difference between business analyst, data analyst, and ML engineer? So, I mean, to the best of my knowledge, these two roles, business analyst and data analysts, are usually roles where you are working with, I mean, these tools. There are quite a few of these visualization tools where you're trying to extract, I mean, insights from data. And you're not necessarily, I mean, to the best of my knowledge, I mean, coding and trying to build algorithms from to get insights. uh, I'm forgetting the name of these tools, but I mean, you should be able to get better idea by just googling, let's say, business analyst, let's say, I mean, Amazon or Adobe. I mean, all of these companies have these roles, and you'll see, I mean, the kind of skills and tools which these roles require. ML engineer is essentially, I mean, again, like I said, I mean, if you're in a startup, ML engineer role, I mean, ML engineer role is expected to do ML research, software engineering, and build the end-to-end pipelines. And I mean, right, to start from the business problem, build a POC, and then take it to prod as well. All of these, I mean, all of these steps require intervention from ML engineers. In bigger companies, I mean, there are these specialized roles where, I mean, ML engineers are usually the ones who take models built by your scientists to prod. And I mean, your scientists are usually the ones who take a business problem and try and build I mean, a POC which shows that it solves the problem. By algos, you mean algos specific to ML or general computer science algorithms? Oh, I mean, general computer science algorithms. You need to be good with, I mean, let's say, depth first search, breadth first search, and all of these dynamic programming algorithms. These algorithms come up in, I mean, different ways, and I mean, in all the places. So, I mean, you need to be good with these fundamentals, and no point in moving on to, let's say, ML algorithms if you don't know, I mean, what dynamic programming is. Next one, on what should we focus more, basic concepts of ML or libraries like TensorFlow, PyTorch. So essentially, I mean, you should be familiar with, let's say, concepts like automatic differentiation, gradient descent. These libraries provide you tools so that you don't have to, I mean, let's say, code gradient descent every time you build a model. But I mean, so PyTorch, let's say, I mean, TensorFlow was there since 2014, 2015. PyTorch came in, I mean, bit later than that, and now PyTorch is maybe more preferable. Now, I mean, some other libraries coming up, I guess. I mean, so if you can go, you can Google as well. But I mean, if I can remember the name correctly, it is JAX. And I mean, libraries will keep changing. Fundamentals and basics will not change, and you should, I mean, see these libraries as mere tools which you can use to, I mean, to be more productive and efficient. That is what all of these libraries help you with. But let's say, I mean, if you are using PyTorch and you are using a weight decay parameter for regularization, but you don't know how it works, then there's no point in, I mean, using, let's say, weight decay and regularization. You should be familiar with what's going on underneath, underhood, and I mean, then only you'll be able to provide real value, I guess, and solve tough problems. Next one, are free courses by universities on platforms like edX, Coursera, Udacity a good way and resource to learn these skills? Yeah, yeah, absolutely. So, I mean, one of the threads, this one which I shared, uh, I can also copy paste. Sorry, I can also copy paste the link over here. So, I mean, this thread contains all of these, I mean, courses and MOOCs which are freely available. And I mean, no doubt, all of these platforms contain really good material to learn. But I mean, one thing which you should be very clear in your mind is that doing these courses and these certificates are not going to help you land a job. Only if you apply these skills and knowledge to a project, to an open source project, to an internship, to a Google Summer of Code project, let's say, only if you apply these concepts somewhere, that is going to, I mean, instill confidence of the interviewer or the potential company which you want to work with, that you have these skills. So I mean, that's the only thing to keep in mind. You essentially, I mean, are free to, I mean, learn from anywhere, but I mean, don't run after, I mean, certifications and all of that stuff. It doesn't really help. uh, okay, next one, would work on a research project with PhD student help to get internship? Yeah, I guess, I mean, this is a reasonable thing to do. And I've seen, I mean, people doing internships in their first year, second year with IITs as well. I'm not too sure if you are familiar, or I mean, about that, familiar with this concept, but I mean, all of these IITs do offer summer internships for college, for students from other colleges. And I've seen people do that, which also, I mean, helps you, I mean, build have a good thing on your resume. And uh, I mean, so any kind of work which delivers some value, and you are able to showcase that value, and I mean, if you are able to turn that work into a research paper at a reasonably good conference, nothing like it. Hmm. Yeah, I guess these were the questions which I got. If you have anything else, I mean, I'll be happy to answer.
Is anybody having any another doubt?
If not, I guess, I mean, you can reach out to me. I'll be happy to help with any of your doubts
But there
on
is
the.
one more doubt
Okay.
in the chat section.
How to know what should we do for data scientist? How should we, acha, if we should go for a data scientist role or a machine learning engineering role? Uh, I mean, I don't think you should be thinking about this. I mean, if you're in second year, third year of your college, I mean, the way to go about this thing is, I mean, wherever you are applying, try and see, I mean, the job responsibilities and job qualifications. That should reasonably give you an idea as to, I mean, if this role is suitable enough for you. And I mean, there are a lot of companies which, I mean, might not even differentiate between these two roles. So I mean, I'll tell you honestly. I mean, so while I mean, while I was going through these interviews, I mean, so I mean, people are ready to consider, let's say, me as a data scientist, as a applied scientist, the job which I got, or I mean, let's say, I mean, research scientist, all of these kind of roles. So the lines are still not very clear amongst these two roles, these 3 4 roles. And the best way to go about is, I mean, before you are applying, I mean, try and get a hang of what this job might entail, and job qualifications and job responsibilities will give you a reasonably good idea. hmm Sir, I'm quite good at Python, but have just completed C++ foundation course. Should I shift to C++ now for data structures and algorithms, or go with Python, which would save my time? I think go with Python. I don't see a reason. I mean, to the best of my knowledge, all of these platforms like Codeforces and CodeChef, these have separate runtimes for Python as well. So it's not that you are losing out on something, I mean, and you will not be able to solve few things because you are working on Python. Uh, and uh, and essentially, I mean, most companies will, I mean, will not say that we want you to code this solution in, let's say, C++. You have the flexibility to work with Python, or I mean, or any language which you want. And I personally prefer Python in interviews. And I mean, because it is less verbose, and you are able to, I mean, what convert your thoughts into code quickly. That's why, I mean, I personally prefer Python, and I don't see a reason, uh, so I mean, that you would need to be working with C++ only. Do most of the time neural networks are preferred over ML algorithms in the industry? No, 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 no. So this is I mean, so neural networks have created quite a big hype, but I mean, unless you are, I mean, so I mean, you are working with computer vision or NLP. Uh, I mean, so these two fields do need a lot of, I mean, deep learning and neural network algorithms. But I mean, if there's this famous quote that 50% of machine learning is only about linear regression and logistic regression, these two algorithms. And even, I mean, neural networks are an extension of logistic regression with multiple layers stacked on top of each other. So, I mean, getting classical machine learning right is very important. And neural networks are important and have been able to push boundaries for a lot of problem statements. And most of them have been in vision, NLP, or in speech. But I mean, you never know, I mean, where you'll land up. So it is very important to have your ML concepts right. Okay. Which one is more appealing? Going for data mining techniques, or applying a technique and refining it? So, uh, okay, my best understanding of this question again is, you're asking, I mean, what should we be doing whenever, I mean, we are trying to solve problems? Try and try and approach a problem from many different techniques, or I mean, try and apply a technique and then try and iterate and improve upon that. So my personal preference is, I mean, to start with a technique, uh, solve the problem, get end results, and then do analysis of those results. This is very important, and this is what, I mean, I've seen a lot of data scientists and ML engineers, I mean, people try and run behind algorithms and I mean all of this stuff. Let's try decision trees, let's try logistic regression, let's try deep learning. But I mean it is very important to analyze your results and see what kind of signals your data has and what all you need to eventually solve that problem. And I mean, so my personal preference is choose a technique which you think is best suited for this problem, and then iterate on that. And only if you face a roadblock, that I mean this function which I'm trying to use to model this problem is insufficient, is not complex enough to model this problem, then only move to a complex model. So I mean that's why it's a good idea to start with simple model, iterate on that, try and see the results, try and see where your model is going wrong, and then add, I mean, then build on that and then add complexity if needed. There's this Occam's razor principle that I mean simple is better than complex, and that's how life is. It is always, I mean, good to keep things simple. What should complete beginners start with? So I guess the answer to this question again is on this slide. Uh, you need to be good with, very good with your software engineering skills, and I mean then all of this mathematical concepts and MLDL concepts is, I mean, what you can get from this thread. Uh, if you'll see this thread, I mean all of this probability statistics stuff and I mean, is I mean, we do touch all of this stuff in 11th and 12th as well. Oh, and all of this is an extension of what we, I mean, did in plus one and plus two. And I mean, I guess I would redirect you to that thread to start with. And I believe, I mean, there are people in this thread who have maybe ordered these courses as well as to, I mean, how you can, I mean, order and I mean these courses in I mean in whatever order you want. So that also I mean you can check out. Anything else?
Thank you very much, sir, for this amazing session.
Thank you
Uh,
so much.
I personally learned a lot from it, and I also believe that people, especially looking for ML as a career option, learned a lot from it. And
Thank
we are good. We are very grateful to know that we have great personalities like you as alumni of PIC, and
thank you.
not only people in this meet, but this meet was also live streamed on PICFest Room. So there was a huge crowd looking forward to the session, and we
Okay.
definitely learned a lot from it.
Okay, thank you so much. So there was this one question, if this is recorded and if people can see it later on, is that possible?
Yes, is it? It is possible if you allow us.
Yeah, definitely. I mean, go ahead with it.
Okay,
You
okay,
should
sure.
try and I mean you should try and share the link with me as well,
Okay, sure.
whenever you
That will
get
be
it.
done.
Mhm.
Sure.
Okay, great then. Feel free to reach out to me if you guys have any other questions. I'll be always happy to help.
Thank you so much, sir. Uh,
Thank you.
on the behalf of Complete Tech and IEEE.
Yeah, thank you so much. Goodbye.
Goodbye, sir. You guys are free to leave now.
Yes, sir. My question is that where we will get the link.
We'll share in the group itself. Ayush, you can stop the recording.
We'll share it in the IEEE group.